Okay, so guys, we need to create the user interface. We'll call it UI underscore drone. Open this one up. I will put in an image first, anchor it to the middle, make it to 0 0. Should be 5 by 5 0.5 0.5. This is basically the aiming part. The cursor mostly is the cursor, so it should be visible all the time. And then I'll put in a text box. This one will say out of range. Change the font to 50. Yeah, good enough. Size to content, make it to center, 0 0, not 0 0. Let's keep it over here, looks fine. Also let's make it red. We want to have another text over here below. That will be, we don't need to change it at this moment, so we want it visible. We don't want it to be visible all the time, so let's just type in visible and we'll create a binding and go back to the drone. Let me just clean this one up a bit. We get distance to a branch, from there we do a sequence. If it is true, I'll make the show message, show warning to true. Also there will be another text over here. This one should be around 30 maybe. Yeah, anchor it to the middle as well. It will just be over there. Size to content, compile, save, go back to the drone. If it is false, we want to set it to false again. Same thing. False. And now we go to the graph, get visibility. We want to cast to drone, get clear pawn, get warning, if it is true I'll set it to visible. If it is false, then we want it to be hidden, and visible we'll put it to hidden by default. So if we open the drone, right, I did not put it in event begin play. So what I'll do is from this one I'll do a create widget and promote this one to a not yet, my bad. First plug in this UI drone, then promote it to a variable, call it UI drone underscore ref. And we do want to add to viewport, and and when we destroy it, we want to remove from parent, and the same thing should be here, remove from parent. Let's see what that does. Only the bottom text box shows out of range. Yeah, so it works just fine for us. Hmm. Yeah, we can bind this one as well on, it would be on the same feasibility, and this text block will bind this one to, okay, create binding, click on create binding and do the same thing we did, cast to drone, get player on. Yeah, we go back to the drone once, we call it countdown, change it to float, we'll set the countdown over here to 5. Over here, not over there, over here. Once it's true, we will decrement float, and if it is false, we want to set the countdown to 5 as well. By default, make sure it's 5 as well, whatever value you want to put. Right, countdown. Right. The other thing would be, yeah, do a sequence from here, put one sequence over there, add a delay of 1, sorry, actually why I'm doing this over there, okay, no, sorry, we want to do it over here, make a delay of 1 second. Actually we should not be decrementing it from here either, I'll just make it from here. Actually I'll put it on a branch as well, so it does not take all the time. We do not want it to take all the time either. If the show warning is true, then after every 1 second it should count down from 5 to 4 and it gets reset, and when it reaches 0, yeah, he pushes back the player. So all we are left with would be to create a shooting implementation, and the other one was the distance, right? So even the distance will be checked at every time. So let's do a line trace for objects. The starting would be get world location. You start it from there, and then we get the follow camera. Get rotation, multiply, sorry, not multiply, get forward vector, multiply it by float, how far you want it to be from. You then add it with the world location, and that would be your end. You can make array of the things you would want. I would want it with all of these: world dynamic, pawn, physics body, if you have vehicle something. I do not, but I'll still make it. I will make an array from actors to ignore and put in as self, and we do want to make sure if it's hit. If it's not hitting something, we don't really need to update it. We can leave with whatever it was. So if we get the impact normal, maybe no, if it is true, what do we want? We want the hit actor, and we want to get distance to is the other actor, and this is the hit distance, and again I'll put in a delay of 1 second. It's your choice what you want. I'll put in a delay of 1 second before updating. And I'll go to UI drone again, and in the graph on this one, right, create binding, do the same thing as the others. Sorry about that. Get hit distance and put it over there. You want to click this drop down, and over here keep it to 1, and half to even. That is fine. By the way, this is probably in centimeters. We want to keep this in meters. I'll divide this, but in actual meter terms it would be quite small, so I'll just divide it by 100 instead of 1,000. An actual dividing by 1,000 would give me in meters, but in gaming the range is a bit off, so to adjust that we just divide it by 100 instead of 1,000. And yeah, so it shows the distance perfectly. In the UI drone I would want it to be over here, maybe. Let's change it to 0 0 so we know where it should be. Size to content, and perfect. This one should be here, and this one, let's change this one to 0 as well, so that I know where the center part would be. Yeah, it's good enough. Now all we are left with is the firing. So we go to project settings, input, action mapping, we call it fire, and we have it on left mouse. Yeah, let's have it on left mouse. In the drone, let's call our fire action event, and once it is placed, we want to spawn a projectile. So let's make an actor class, call it bomb. We want to add a static mesh, add whatever static mesh you have. I'll just add a sphere, and with 2.1.1.1, add in a particle effect system, add in the fire, okay. The last thing I would add would be a collision, a sphere collision. Let's make it 260. That is perfect. So you don't have anything, right? So, and the other thing we would want is to add a projectile movement, the gravity initial speed, let's keep it to 5000. Rotation, gravity scale 0, rotation follows velocity, vertical, no, nothing, and I think everything is good enough. So what we want to do is, on component hit, if it hits something, we want to destroy the actor, but before that we would want to spawn emitter at location and place sound at location. Get actually we don't want that, we want to get the static mesh, actor, get location, and we'll plug it in. This one would be the explosion, and this one would be the explosion 2 as well. And for this explosion, let's just minimize the volume. The volume is way too much. Volume, let's make it to 0.125, whatever it is. And I want to spawn actor from class. I'll get the capsule component. I'll get not spawn, get world location, split, make vector, split this one as well, x, y, and it should be a bit of a minus, maybe 50, and get forward vector. Get into 50. Actually, I just don't need that. Never mind. Yeah. We named it bomb. Try to adjust location, but just spawn it over there. Yeah, we don't want to spawn from there. Right. Get forward vector. No. Get world location. Get rotation. Forward vector. We want to multiply it by 50 times. Now we want to add this one, vector plus vector with the world. Make vector, split this one, x, y, and the z would be minus 50 below. Let's see now. Right. Let's make it to 200. It's just forward vector. Rotation, and this one should be 0.1, 0.1, 0.1. Yeah, there we go. Yeah, we don't want it to be minus that much. Yeah, now it's on point, shooting on point. Whatever we aim, we'll get it over there. Now you might be thinking why it's not destroying it. Let's do it with the sphere. Yeah, we want to make sure it's not equal to self. It's not equal to, let's do a cast to drone. Yeah, it's not. What we can do is get to 500. To 50. What the fuck? from here. Times let's do something. I'm pretty much sure it's colliding with that drone, so what we can do is just keep the camera in front. Let's right. Okay, over here we make sure that the cast is to the third person. Okay, so we need to cast to the third person character and make sure that this is true. And if it falls, we need to cast to static mesh actor, other actor, same thing over here as well. If it is true, we would want to do the same thing. Also, the best thing would be just to have it a bit above so that it does not, yeah. Okay, yeah, right. We want it from follow camera. Now let's check it. Yeah, now we have no issues. So in the bomb part, we have to make sure that the projectile move on the on the sphere. On the sphere, we click on the on component begin overlap, and from there we cast to the third person character and make sure if it is equal to the third person character. If it is true, then we spawn the location, we spawn emitter at location, play sound and destroy the actor. We do the same thing, and we also check if it's false. We make sure that if it's the static mesh actor, and if it's true, we do the same. Now the reason it's not working with this static mesh actor is because the collision for these are set to false. So what I need to do is select them all. I want to set it to true and would be block all. Let's see now. Still no. Let's make it to custom. Make it to world dynamic. Let's change it to block overlap. Oh my god. Yeah, we can't have it to overlap. We need to have it dynamic over here. On the bomb over here, let's check. We need to do a overlap all. mm, overlap all. Hmm. Should we block all? I think this is not getting set to true. I think I need to do one from here, sequence. There's something wrong with this one. Custom, get world dynamic. Go to the bomb. Let's change the sphere collision to be 90, a bit bigger. It was not big enough to collide, so that was the issue. So now we have completed almost everything, and you can have it on a damage, so it does damage to the player once it's colliding. Okay everyone, so let me go through this once, try to explain everything that I have done so far. So in the drone is basically a duplicate of this third person character, and in the drone we have the mouse input and movement input same as Unreal provides us with. The only change in the movement input was made over here in the move right input axis. What we do is we take the axis value, we interpret from the current to the target, that is our axis value, over delta time with the speed of 2.0. Then we set the current write value from there and multiply it into 10 times to get our roll, the amount of roll that it will be doing, either -10 or +10 depending on the movement keys A or D. And the set control rotation is what actually rotates the camera, gives the rotation sway feel to it. And then we made this input axis called move up. It is basically the spacebar and the left control. Spacebar has a scale value of 1, left control has a scale of -1. What we are doing is we are taking the axis value and multiplying it into 5 times and putting up into the delta location Z. So when it is negative, it will go below, as in -5, -10 and -15, and for the positive it will go 5, 10 and 15 and so on. Also we don't want the drone to continue to move downward or below the ground forever, so we are limiting the movement by mm, putting a -500 limit on the negative and +2000 limit on the positive. uh, we are in begin play, we are actually getting the capsule component world location and setting it to a variable, storing it to a variable, and the same thing we are negating and adding it to the clamp. What clamp does is basically it clamps the z value within these values. So whatever the world location would be, -500 would be the limit minimum that it can go, and positive is the maximum it can go. So that's what it's doing. And then we have the deployed drone. If I'm pressing the input action deploy drone, it checks if the character reference is valid. If it is valid, we destroy the drone. We remove the UI drone widget reference from it and possess our player character. And in the event tick, the first thing is to uh, do the post process enable and disable. This is the enable and this is the disable from false. So what we are actually checking is if the distance of the drone from the player character is more than a specified range. If it is true, then we are enabling the post process and we show the warning sign. And if it is false, we disable the post process and we stop showing the warning sign as well and set our countdown timer to 5 again. But once it's true, what it does is there's a delay of 5 seconds. Within these 5 seconds you have the time to go back within range. If you go back to the range, we again stop the warning sign and the post processing. But if it is true, we remove the UI reference again from the viewport. We destroy this actor and possess the player back again. So that was our first part. This is a part of this only. If our show warning is set to true, we are having a delay of 1 second. So in delta tick, at every, let's say, not seconds, milliseconds, in milliseconds it is counted. So if I just plug in without having this delay, it will be counting to milliseconds and it will be 120 milliseconds or something like that, which we don't want. So for every 1 second we want to negate the countdown to -1. So it's 5, then after 1 second it will be 4, after 1 second it will be 3 again, and so forth. And the last thing we are doing is a line trace from the drone. We are doing the line trace from the drone capsule component. We are getting the world location, and that is our start for the line trace, and for the end is the follow camera. We get the world rotation and the forward vector. The forward vector is basically, if I have to explain, let's say this is our drone. Okay, this is our drone. We are tracing it at a certain distance of 10,000 maybe, let's say. So we are tracing it. What forward vector does is, actually by the, if we are doing the get world location, it gets this location, specifically this location in the 3D world, but you always want it to get this forward place. You don't want the ray trace to be sideways like this or like this. You don't want it. These are not correct. What I want is this one. This is the correct one. So how do I get it? But you get the rotation of it basically. So it of the camera, so it gets which way you are looking at, which is this one, and it gets the forward vector of it basically. Actually the rotation does not get the this direction. What rotation is getting is the coordinates of where you are looking at this moment, and the forward vector gets this direction, the forward direction where you are looking at. So if you add this forward vector of the rotation and the world location, you get this straight line basically. That's what it's doing. So once we get that, we multiply it into 10,000. So again, we want to line trace to a certain thousand distance maybe. What forward vector gets is this direction, but it does not know how far you want it to be. For that far away distance, you need to multiply it with 10,000, and that is the distance it gets as the end point. It starts from your drone location and it goes 10,000 in the forward direction. This is 10,000. So basically you are doing from this world location to here 10,000 in the forward. So that is our end. The object types, it's a necessity. If you don't give it and try to compile it, it will throw an error. It's a necessity because you have to line trace for certain objects, right? You are line tracing for some objects, so you have to specify what those objects are. These object types could be world static, world dynamic, pond, physics, body, vehicle, and destructible. So you want to make sure what you are actually trying to get from this line trace, and you also want to ignore this actor which you have right now. You want to ignore the drone while ray tracing, otherwise it what might happen is maybe this is the drone and the camera is here. You are line tracing from actually the camera, but there's the static mesh of the drone. So what it will do is it will just hit over here, and let's say he will just give you the hit location to be on the drone itself. We don't want that. We just want to ignore this drone altogether, make it invisible. So that what it does, actors to ignore, is we make an array because it takes an it takes the input of an array. So we make an array and plug in ourselves. We can try to add as many as we want if we want to ignore more elements, but over here we do not want to, so we just ignore ourselves. And then we make sure that the return value is true. What it does is that the line trace was successful in and it actually hit something. Let's say we are looking at the sky, it will never hit something. We don't want this line trace to success for things that are way far away or for the things that we don't really need. So what it is does is it filters out the line trace. It saves on processing power. So once it is true, we get the out hit, we break the out hit result, and from there we get the hit actor, and then we check the distance from the drone to that hit actor, and we are dividing it by 100 because this one is in centimeter actually, but we should actually multiply it by 1000. But game engines have a different set of distance calculation, so I'm just dividing it by 100 because it suits me, my style of programming. So I just gave it to be 100. You can stick to 1000 if you want to actually do it to meters, actual meters, but I'm doing to 100. And then I'm just storing it in a float that I made uh, and called it hit distance. So I'm just storing it over here. And from here we go to the UI. We put in some text over here, three texts basically, and from the first text we are binding the visibility because we don't want it to be visible all the time. So what we are doing is we getting the drone, we check for the shows warning sign. If the show warning sign is true, only then it should be visible. If it's hidden, it should not show up. It's simple as that. Same goes for this what do you call it, the timer as well, of how much time you have left to get in back in within the range. And it has the same logic, the show warning visibility check on the bind. And for this text, what we are doing is we are casting through the drone and getting the countdown value that we just yeah, we are just getting the countdown value from here. If it's decrementing or it is at 5, we just get that and just return it to just plug it into the return node, and it already does the conversion from float to text, so we don't have to worry about it. And then maximum, we don't actually have to worry about this one either. And this is the last one. This is actually the distance that we are checking, and this is always visible, so we do not have to set the visibility for this one. We do not have to bind it with somebody, but for the text we are binding the text to the hit distance that we calculated over here with the line trace. We just plug that in, and fractional digits, we just only want one fractional point, we don't want more than one. So that is it more or less with the drone and the drone one. And even in the third person character we do not have much. The only thing we have is the deploy drone. If we press the deploy drone button, we make sure that we are not falling, the character is not falling, and if it's not falling we set the movement mode to none, so that if you are running and then press Z, it should stop any animation, running animation or walking animation it's playing, because then the movement sets to none and all the animation becomes invalid for that part. And then we spawn the drone. Where do we spawn the drone? We take the capsule component of this mesh, we get the world location, and from the Z we add 500 to it, and then we just spawn it. That is our transform location. For the rotation we get the capsule component world rotation and plug it in, and for the collision handling override we just try to adjust location but always spawn, and from the return node we just possess the drone that we have on Z. And that is all we have for this one. It's a very easy process to get this drone working. And the final thing was the fire. The final thing was the fire, and by simply firing we are in the from the drone. If we press the fire, we spawn the actor, we spawn actor from class, and that class is the bomb. From the follow camera we are getting the world location forward vector same, and the world location we multiply it into 50 times, so 50 centimeter in front of the drone we are spawning it and adding it to the world location, and from that we get the vector, and that is our transform location. And the rotation is the world rotation, the camera is looking at, whatever the camera is looking at is our transform rotation. And the collision handling is same, try to adjust location but always spawn. And before I move to that, there are specific things necessary for this drone to work. We click on the character movement. Default land movement mode should be flying. The default water movement mode should also be flying. The friction, make sure the braking friction is 2. Braking friction factor is 2. Use separate braking friction is set to true. After that only you can set the braking friction to 2 as well. And you have to make sure the falling lateral friction is 1 as well. You can make it more, but the thing is you want the drone to sway a bit to the left or to the right before stopping completely. So this is how you get it actually. If you set it to 1, if you set it to 2 or above, it will just stop whenever you just stop it. It won't sway a bit further to the left or the right. So it just gives a more natural movement. That is all from this one. From the next video I'll start Unreal basic courses. If you are new to Unreal, you should watch those videos, because I might have been going a bit fast for these tutorials, because these tutorials are not actually for the ones who are starting with Unreal. This is a bit for those who have been using Unreal for 3-4 months. So I'll see you guys in the next course. Thank you for watching, and if you liked this video and found it helpful, please like and subscribe. That actually helps me a lot. Thank you guys. See you.